we have different materials here. We have a rock, this yellow paper, clay, water, ice. In here there is oil and a piece of copper wire. We are going to learn the properties of these materials, such as strength, brittleness, malleability, ductility, density, the boiling point, the melting point, and the freezing point of a material. So in this video, we will learn and define all of these properties. The first property of matter we are going to talk about is strength. Strength is the ability of a material to resist stress or strain. So that is the definition of strength, the ability of a material to resist stress or strain. So let's compare this rock and this piece of paper and see which of the two is either strong or weak. So which one of the two between this paper and this rock would you describe as being strong or weak? If I were to put this rock under stress or strain by squeezing and stretching it, we can all clearly see that nothing is happening. I will need a lot of strength to be able to break or to deform this rock. So a rock has strength, meaning it can resist any stress or strain that I put it through. So we would say that this rock is actually very strong because it has an ability to resist stress or strain. However, if I were to put this piece of paper under stress or strain, stretching, squeezing it, almost immediately the paper deforms, right? This means that this material does not have a lot of strength, meaning that it is actually quite weak. So for this material, this paper, it really doesn't resist stress or strain. So we would say that this type of material has very low strength. The next property of matter is brittleness. A brittle material is a material that is hard but very easy to break. Can you think of such a material? A material that is hard but it's quite easy to break it. When you hold a glass, it's very hard, right? But one mistake and you drop it on the floor, it will break quite easily. Another example of a brittle material can be ceramic. There's also a disease where people have brittle bones. It means their bones, in as much as they're hard, they're very easy to break. Another property of matter we can talk about is malleability. A malleable material is a material that can be hammered or pressed into shape without breaking or cracking. So if you can have a material and you press on it or you hammer it, but it doesn't actually break or crack, we would say that material is very malleable. An example of such a material would be clay. Clay is very malleable. I can press it without it breaking or cracking. And I can press it into any shape that I want. I've seen kids play with this and they make this nice shape. I don't want to stop playing now. So clay is a very malleable material. Another example of a malleable material can be dough. If you're making steamed bread, you know when you're pressing against it that it doesn't actually break nor crack. The fourth property of matter we can talk about is ductility. A ductile material can be stretched into a wire. Can you think of such a material? An example of a ductile material can be this, or can be copper. So here I am holding copper wire. So from copper, they can make this very long. So they were able to stretch this copper into a wire. And that is an example of a material we would say it's ductile. It can be stretched into a wire. The fifth property of matter we can talk about is density. Density describes the mass per unit volume of a substance. It basically means how dense, or in more simple words, how heavy a material is within a given volume. Some materials are much more heavier or are denser than other material. So like I mentioned, density just refers to the mass per unit volume of a substance. For example, oil that we have in here is not a lot of oil. Oil is expensive these days. Is less dense than, let's say, water. So if you take water, there's water in here. This oil is less dense than it. So if I were to drop oil into this water, you can clearly see that it will float. It doesn't go to the bottom because the water is substantially much more heavier than the oil. I don't know if you can see from that angle, but you can try this experiment yourself at home, because now can actually tell a difference. So that is what density is. It's how heavy or how dense a substance is. It's the mass per unit volume of a substance. One of the most interesting things about materials is that they have something called a melting point. So different materials will have different melting points. A material's melting point is the temperature at which a solid, if you are heating it up, becomes a liquid. So we have a change in the physical state of this substance, any substance or any material you can think of. So a substance's melting point is a temperature at which a solid, given sufficient heat, becomes a liquid. So the melting point of ice is 0 degrees Celsius. So the melting point of water is just 0 degrees Celsius. So if you put this water in a fridge, the temperature there is much lower than 0 degrees. This is why the ice will be, or the water will actually be a solid. The moment I've taken it out of the freezer, the temperature in the environment is much higher than 0 degrees Celsius. That's why, as you can see at the bottom, that this ice is actually has started to melt. So its melting point is 0 degrees. Materials do not only have melting points, as we talked about just now. They also have something called boiling points. So this is another property of materials we can talk about. I want you to think of a material's boiling point as the temperature at which a liquid which is being heated becomes a gas. So at that temperature, when you are heating a liquid and it becomes a gas. An example of that would be, think of if you have water. So if I were to take this water, put it on a stove or something, and it reaches a temperature of about 100 degrees Celsius, this water will start to boil, or this liquid water will start to boil. And when it boils, you will see at the surface of this water, you start going to see a little bit of vapor. So it means that the boiling point can be thought of as the temperature at which a liquid, such as liquid water, given sufficient heat, becomes a gas. But typically for your memo, if you're writing a test, this is not the definition that they use. So the definition that I want you to also learn is that the boiling point is the temperature of a liquid, any liquid, at which its vapor pressure equals the external, the temperature outside, because there will be, maybe you are sealing this material in a container. So the moment the vapor pressure as it's boiling is equals to the atmospheric pressure, the pressure outside, this will begin to boil. So the temperature of a liquid at which its vapor pressure equals the external pressure or the atmospheric pressure. This is how we can typically define the boiling point. We have said that materials have a boiling point, a melting point, and now I'm here to tell you that materials also have a freezing point. A freezing point, that's very interesting. And different materials will have different boiling points. Water won't necessarily boil at the same temperature that oil boils at. So different materials have different melting points, different freezing points, different, what's the other one? Melting and boiling, and then freezing point. So be aware that different materials have different freezing, melting, and boiling points. So this is the last property that we're going to talk about in this video. You can think of a material's freezing point as the temperature at which a liquid becomes a solid as the temperature decreases. So if I were to take water, see at the bottom of this we have water, put this in a fridge, it will start to freeze because I am removing it from heat. Remember, the temperature outside the fridge is much higher than the temperature in the fridge. This is why this water will begin to freeze by the removal of heat, by taking it from an area that has a high heat or that has a higher temperature to an area which has a much lower temperature. So it's very important for you to understand all of these properties as well as the different states of matter.